Hello children, let's continue exercise 5.1 continuity. Sixth question. Find all points of discontinuity of f where f is defined by f of x equal to 2x plus 3, x less than or equal to 2, 2x minus 3 when x is greater than 2. So if it is less than or equal to 2, then it is 2x plus 3. Then if x is greater than 2, then f of x is defined to be 2x minus 3. So to the left of 2, that is x is less than or equal to 2, then it is defined to be 2x plus 3. To the right of 2 is 2x minus 3. So we have to consider three cases. Let k be any real number. Then we have to consider three cases. K is less than 2, k equal to 2, or k is greater than 2. So first case, k is less than 2. So we have to check the continuity of the function. So when k is less than 2, f of x is defined to be 2x plus 3. So f of k is 2k plus 3. So to check the continuity of the function, so we need to use limit x tends to k. When k is less than 2, the function f of x is defined to be 2x plus 3. So 2x plus 3, which is equal to 2k plus 3. These two are equals. So we can say that it is continuous for k less than 2. Where k is any real number. So case 2, let's take value k greater than 2. So if k is greater than 2, so to the right of 2 we have f of x defined to be 2x minus 3. If x is greater than 2. So case 2 is k greater than 2. So f of k is 2k minus 3. Then we need to check the continuity of the function. So limit x tends to k, f of x, which is equal to, here k is greater than 2. So for f of x defined to be 2x minus 3. So limit x tends to k, 2x minus 3, which is equal to 2k minus 3. So these two are equal. Then we can say that it is continuous for all real numbers greater than 2. Consider the third case, k equal to 2. So f of x is 2x plus 3. So f of 2 is 2 into 2 plus 3, which is 7. Now we have to find left hand limit and right hand limit. So left hand limit, which is limit x tends to 2 minus f of x. To the left of 2 we have 2x plus 3, which is equal to limit x tends to 2 minus 2x plus 3, which is equal to 2 into 2, 4, 4 plus 3 is 7. And we need to find the right hand limit. Limit x tends to 2 plus f of x, which is equal to the right of 2 we have f of x to be defined as 2x minus 3. So limit x tends to 2 plus 2x minus 3. So 2 into 2, 4, 4 minus 3, which is 1. Here we can see that these two, LHL and RHL, which is not equal. At k equal to 2, left hand limit, which is not equal to right hand limit. Hence the function f is discontinuous at k equal to 2. 8th question. Find all points of discontinuity of f where f is defined to be f of x, which is equal to modulus of x by x if x is not equal to 0, and f of x is 0 if x is equal to 0. So we have to redefine this. So mod x is positive x when x is greater than 0, and it is minus x when x is less than 0. So we have to rewrite this as f of x equal to modulus of x by x. So when it is positive, so x by x, we get 1 if x is greater than 0. And if x is equal to 0, then f of x defined to be 0. When x is less than 0, then it is defined to be negative minus x by x, which is minus 1. F of x is defined to be 1 if x is greater than 0, and it is 0 if x is equal to 0, and it is minus 1 if x is less than 0. So using the number line, so to the left of 0, so when x is less than 0, it is minus 1, and when x is greater than 0, to the right of 0 we have 1, and at x equal to 0 it's defined to be 0. Then we have to consider 3 cases in which we have to find the continuity of the function. Case 1, when x is less than 0, then f of k, which is equal to minus 1. When x is less than 0, then it is defined to be minus 1. Then limit x tends to k, f of x, which is equal to minus 1. Here we can see that these two are equal, so it is continuous for x is less than 0. Then consider second case, x equal to 0. Then we say that f of 0 is, when x is 0, then f of 0 is 0. So taking right hand limit, limit x tends to 0 plus f of x. To the right of 0, we have f of x defined to be 1, so which is equal to 1. So we can see that at x equal to 0 we have f of 0 equal to 0, right hand limit is 1. Then left hand limit, limit x tends to 0 minus f of x. To the left of 0 we have f of x defined to be minus 1, so which is equal to minus 1. We can see that left hand limit which is not equal to right hand limit, then limit does not exist. It is discontinuous at x equal to 0. Then case 3, when x is greater than 0. So when x is greater than 0, then f of x defined to be 1. So f of k is 1. Then limit x tends to k, f of x, which is equal to limit x tends to k. So we have, when x is greater than 0, we have f of x defined to be 1. So limit x tends to k, 1, which is equal to 1. So these two, it is continuous at x is greater than 0. 10th question, f of x equal to x plus 1 when x is greater than or equal to 1, and x square plus 1 if x is less than 1. So we have to find all points of discontinuity of f when f is defined. So using the number line, when x is equal to 1, so to the left of 1, when x is less than 1, then f of x is defined to be x square plus 1. When x is greater than 1, it is defined to be x plus 1. When x is equal to 1, then f of x is also defined to be x plus 1. So we have to consider 3 cases in which we have to find the point of discontinuity. Case 1, when x is less than 1, then f of k equal to k square plus 1. When x is less than 1, we have x square plus 1. So f of k is k square plus 1. Limit x tends to k, f of x, which is equal to limit x tends to k, f of x. When x is less than 1, we have x square plus 1, which is equal to k square plus 1. So these two are equal. we can say that it is continuous for x is less than 1. Case 2, at x equal to 1. Then f of 1 is, so at x equal to 1 we have x plus 1, so which is 1 plus 1, it is equal to 2. Then right hand limit x tends to 1 plus, to the right of 1 we have x plus 1, so limit x tends to 1 plus f of x is x plus 1. So to get the limit, substitute the values, we get 1 plus 1 which is 2. So right hand limit is 2. Then left hand limit x tends to 1 minus f of x, which is equal to limit x tends to 1 minus, to the left of 1 we have x square plus 1. So to get the limit 1 plus 1 which is 2. Here we can see that right hand limit which is equal to left hand limit, and we get the values of f of 1 which is equal to 2, which is limit x tends to 1 f of x, which is equal to 2, which is equal to f of 1. It says that f of x is continuous at x equal to 1. So third case, when x is greater than 1. When x is greater than 1, we have f of x defined to be x plus 1. So f of k is k plus 1. So limit x tends to k, f of x is limit x tends to k, x plus 1. So we have k plus 1. So these two are equal. We can say that f of x is continuous at x is greater than 1. So question number 14, discuss the continuity of the function where f is defined to be 3 if x lies between 0 and 1, and f of x equal to 4 if x lies between 1 and 3, and it is 5 if x lies between 3 and 10. Using the number line, at x equal to 0, the function is defined to be 3. So between 0 and 1, f of x is 3. Then at x is equal to 1, it is defined to be 3. Then between 1 and 3, it is defined to be 4. So between 1 and 3, the function is defined to be 4. So at x is equal to 3, the function is defined to be 5. So at x equal to 3, it is 5. Then between 3 and 10, we have f of x is defined to be 5. Then at x equal to 10, we have it is defined to be 5. Here f of x equal to, so consider the first case at x equal to 0, then f of 0 which is equal to 3, then limit x tends to 0, f of x which is equal to 3. Then we can say that f of x is continuous at x equal to 0. So consider second case, x lies between 0 and 1, then f of k equal to 3. So limit x tends to k, f of x which is equal to limit x tends to k. So when x lies between 0 and 1, the function f of x is defined to be 3. So limit x tends to k, 3, it is equal to 3. Here we can see that these two are equal. F of x is continuous at x lies between 0 and 1. So third case, at x equal to 1. So f of 1 equal to 3. At x equal to 1, then f of x is defined to be 3. Left hand limit x tends to 1 minus. To the left of 1, of f of x. So to the left of 1 we have f of x is defined to be 3, so which is equal to limit x tends to 1 minus of 3, which is equal to 3, and right hand limit x tends to 1 plus. To the right of 1 we have f of x is defined to be 4, so limit x tends to 1 plus, which is 4, equal to 4. Here we can see that limit x tends to 1 f of x. Here we have 3 different values. So LHL, which is not equal to RHL, so it does not exist. Hence we can say that it is discontinuous at x equal to 1. So consider fourth case, x lies between 1 and 3. 1 and 3. Here f of k equal to 4. So when x lies between 1 and 3, then the f of x is defined to be 4. We have f of k equal to 4. Then limit x tends to k, f of x, which is equal to limit x tends to k 4, which is equal to 4. The function f of x is defined to be 4. Here we have these two values are equal. We can say that f of x is continuous in x lies between 1 and 3. So case 5, at x equal to 3, we have f of 3, which is equal to 5. It is defined to be 5. So left hand limit x tends to 3 minus, to the left of 3 we have the function is defined to be 4, so it is equal to 4, and right hand limit x tends to 3 plus, so to the right of 3 we have the function is defined to be 5, so 5, which is equal to 5. You can see that limit x tends to 3 is unequal, which does not exist. Left hand limit is not equal to right hand limit, then it is discontinuous at x equal to 3. So consider sixth case, x which lies between 3 and 10, f of k, which is equal to between 3 and 10, f of x is defined to be 5. Then limit x tends to k of 5, which is equal to 5. Hence we can say that f of x is continuous at x which lies between 3 and 10. So consider seventh case, at x equal to 10, we have f of 10, which is equal to 5. It is defined. Then so left hand limit x tends to 10 minus f of x. To the left of 10 we have f of x is defined to be 5. So limit x tends to 10 minus of 5, which is equal to 5. So f of 10, which is equal to limit x tends to 10 minus of 5, which is equal to 5. Otherwise it is f of x, which is equal to 5, which implies that f of x is continuous at x equal to 10. So we do not find right hand limit, as it is not possible. So we are finding only left hand limit. Then both are equal, so we can say that f of x is continuous at x equal to 10. We will continue the rest of the questions in the next video. Thank you, children.